All right, we're going to do a quick example here applying the difference of squares formula here. It's just something a little bit different here. So recall, what is the difference of squares formula? We have here expression to the power of 2 minus another expression to the power of 2 is equal to x minus y times x plus y. So the idea with difference of squares is you need an expression raised to the power of 2 difference, hence subtraction, of another expression to the power of 2. It does not just have to be one variable, and we see that being applied here. You'll notice here I have a minus b to the power of 2 minus. Now this is a little bit different here. I have the b minus c is being raised to the power of 2. However, this base of 2 is not applied yet to the 4. So we have to adjust this expression a bit so that we can apply our difference of squares formula. Doing so, we get the following. And you'll notice here I tucked in this power of 4 into the brackets here so that the exponent can be applied to it, change it to a 2. Now we have an expression to the power of 2 minus another expression to the power of 2, and we have that difference between them. So again, you can let x equal a minus b and y equal 2 times b minus c, and we can apply this formula. Doing so, we get the following. You'll see here I have here x minus y times x plus y. Expanding and simplifying, we now have a factored expression. So we start off with this expression here, not factored, applied our difference of squares, and now we have a fully factored expression on the bottom. All right, let's take a look at this example here. This is another example of a difference of squares question. You might not see it directly, but looking at this expression, I want to be able to factor this. Initially, you don't really see a difference of squares being set up. Like I sort of have something on this side here, but I don't have a difference of squares here. The observation here is to take a look at this first, and you'll notice this can be factored. So first, let me factor out that minus sign. So let's do that first. We get the following. And you'll see here, by factoring out that minus sign, this expression here, a squared plus 2ab plus b squared, that's exactly equal to a plus b quantity squared. You'll notice, square the first, we get a squared. First times second times 2, we get 2ab. And square the last, we get b squared. So therefore, I can replace this expression here with a plus b quantity squared, giving us. And you'll notice here we almost have our difference of squares formula being applied. I have an expression. I got that power of 2. I have my difference. I just got to adjust this here, and I have to put this 9 within the exponent of 2 here, giving us the following. And now you'll see here I have a difference of squares. This represents my x, and this represents my y. Subbing this in, we get. You'll notice here this is x minus y times x plus y. Watch your brackets here. When you do subtract, you have to put brackets around that a plus b, else you would forget to distribute that. So distributing, we get 3r minus a minus b times 3r plus a plus b. And now you can see here we are fully factored. Again, 2 steps to solving this problem. We had to first factor out the minus sign, giving us this expression here, and then making the observation that that was actually a plus b quantity squared. From here, we ended up with a difference of squares. Slight adjustment and applying our formula, we have a fully factored expression. Thank you.